What's up, what's up? Welcome back. Today we're working on my Git GUI, kind of. So, for reasons I'm not going to get into right now, I'm writing a Git GUI, partially for fun, partially because I think that there are features that I want, whatever. And one of the many things that this Git GUI does is he shows a diff. So I'm gonna see here, click on a commit, it tells me the commit message, shows me the diff, shows me what files changed, blah blah blah. And then one of the features of this guy is motivation to some extent is there's move tracking, so I can see, oh, here's a move, and where does it come from? Oh, this came from line 252, and if I look at 252, there should be a corresponding deletion over here. So somewhat working great. Problem is that with the current implementation of diffing, I need to have a lot of memory in order to actually execute a diff for these guys. So, right, if I have a cargo lock file change, he says hey, I need 250 fucking megabytes to calculate the diff of this thing, which is insane. That's an insane amount of memory to need for a not very large file. Right, if I look at my cargo lock file, it's 96K, and if I will keep in mind that the diff algorithm is running on lines, and so this is the memory scales with that. So if I say WC-L and I look at the cargo lock, it's 4,000 lines, needs 250 megs of memory. That's so much memory for 4,000 things. And so what we're looking at is how can we reduce that? So we've been working on kind of moving from this quadratic version of this algorithm that we're using to calculate the diff into this linear one. So what is this algorithm? This is Meyer's diff algorithm. It's the same one that everybody fucking uses. Some guy in the 70s or something, his name was probably Myers, wrote a paper, and he's hey, we can pretty efficiently figure out the shortest amount of edits we need to do to get from one string to another. So in this example, I have let's maybe pop open an editor here. And in this example, we have 1, 2, 3, 4, 5, 6, 7, 8. And maybe we'll put these as, we'll slap them all together here. And then we're trying to get to 3, 4, 6, 5, 1, 6, 2, 9. And the idea is you start with 1, right? And you say okay, well, I delete 1 and 2, and then I have 3 and 4, those line up. And then I need to maybe delete the 5 as well. The 6 is there. We'll throw in a 5 here and a 1 and a 6 and a 2 and 9 and delete the other ones, the rest of something, right? There's some sequence of actions that you do to get from one state to the other state. And you can kind of represent these sequences as moves on a 2D grid. So the idea is that we start up here, and here's 1, 2, 3, 4, 5, 6, 7, 8 on the top, and 3, 4, 6, 5, 1, 6, 2, 9 on the bottom. And the idea is that there are diagonal moves in any area where the destination is the same as the source. So here we have 3 and 3 here. So a move into 3, 3 is a diagonal. And then here we have 4, 4, that's a diagonal. 5, 5, diagonal, 6, 6, diagonal, 6, 6, diagonal, right? And so the way this algorithm works right now is he basically just walks diagonally across this thing, doing what is essentially a breadth first search. But the trick is, when he sees a diagonal, he just shoots the bottom of it. And so now when we do our next set of moves, he doesn't actually continue from up here, he continues from here. And so every time he sees a diagonal, he shoots down it. And the idea is that by doing this, you should get to the end in the least amount of steps possible. The problem is that in order to backtrack to figure out what this edit sequence actually is, this corresponds to delete, delete, nothing, nothing, add, nothing, delete, add, right? That's what this means. You traverse one without the other, it's a deletion. You traverse one without the other, it's an add. So the problem is we have to now that we've figured out how many steps, how many steps it took to get here, we have to figure out how we got there as well. So we don't know which path is going to be the successful one until we get to the end. And so we have to remember which path we took for every single branch in the tree, and that is an n squared problem, where n is the number of lines in A and B. Is this diffing car by car or line by line? So this example is diffing car by car, but it's like the diff algorithm, or the API to our diff is like any sequence of equality comparable things. So you could do it on characters, you could do it on lines, you could do it on buffers, you could do it on whatever you want, as long as you like split them up. So what we're doing in our Git GUI is we're loading the file, splitting by lines, and then feeding into the diff algorithm. Okay, so what is the linear version of this? The linear version of this is you can actually do this walk without remembering the whole path. So even line by line, it's exploding memory usage. Exactly, yes. So here we're seeing the same thing. Fuck. This visualization broke, I think. Oh, that sucks. Let's see if we can, hold on. We can get back to a state where it's okay. I was messing around with this a lot last night, trying to clean it up. Maybe if we go check out this one. We'll just go back a little bit and see. Sorry about that. Much better. Okay, so if we run this version of the algorithm, we're still walking the same path we walked last time, but the green lines are only remembering the last move. And so if we only remember the last move, we can walk all the way to the same point at following the same path, but we just don't know how we got there. And which seems kind of not very useful, but it is useful, because what we can do now is we can run the algorithm both forwards and backwards. Let's see. Backwards. And so we can run it backwards, doing the same thing, and this path is almost the same. We noticed yesterday that there are some very slight differences, but it's like very close. And so the idea is, if we run it forwards and backwards, at some point they'll run into each other. And we can say, hey, let's bisect the problem at the point where they smack into each other. And so that's kind of where we're at. And so we've been kind of like doing like the prep work in order to get to that point. So we've got this like ability to kind of limit like the area that we're going to do the diff on. So we can say like, let's do this like sub slice, right? We can like run on this sub area of the graph. And so the idea is we figure out where they smack into each other. We break up the diff into these smaller slices, and once we have small enough slices, we can run the quadratic version on those small slices, and we'll be happy. And then we just have to stitch them together. And this provides almost as good diffs. It still, as far as I understand, it still provides a minimal edit. So basically, the minimum number of changes are still preserved, but the order in which those changes are made might differ a little bit, because when you have like the full quadratic version, you can kind of, if there are like 2 points of equal quality, you can pick which one you want based off some heuristics. So in our original algorithm, we're preferring deletes over adds because you want to see, I removed this, then I added this. You could do it the other way. I added this and removed this, but like whatever. Like you want them to be like grouped together instead of like add, remove, add, remove, add, remove. So there is some difference there, but overall pretty much the same thing. And so the plan for today is to take like our current state and try to get into the state where we can run it. We can split it up, I guess. So I think our steps are going to be, we're going to run the algorithm forwards and backwards. Right now we only do one or the other. So we're going to have to run it both at once, figure out how to determine where they meet. Then once we find a meeting point, we have to split up our diff into like smaller diffs and then execute those. And eventually we'll have split it up to the point where we can bail out. We'll find our like exit condition. And then we have to like run the sub problems in like backtracking mode. And then at the end we have to like convert that all to a diff. Which I thought this would be the last stream, but now when I read all that out, it's like, that might be a lot. We'll see. We'll see how fast we advance. But before all that, let's fix forgetful visualization, because I want to start from a good state. I want to start from a good state. Okay. So let's just see what the fuck was going on when we ran forgetful. So it looks like what happens in this, like, how do I say this? What are we, like, trying to render here? We try to render the last move we did. And in some cases, a single move ends up being like 2 moves, right? So here, that's like 1 move. But here, when we move from this point to this point, we're going to see this diagonal and jump down it as well. And this ends up being like 2 lines that are traversed, this one and this one. And so it looks like in forgetful mode, we are only showing the second of the 2 moves that we're doing. So there's just a bug there somewhere. Just a little bug there somewhere. So we can probably look at our lib diff. We have our like diff algo state machine. And one of the many things that he does, or maybe one of the 2 things that he does, is he like gives us some debugging info at each step of the algorithm. And as part of that, he does this like backwards iteration where he tries to walk backwards the trace with some limit. So it looks like this might have to be d-1 in terms of like how far we're willing to walk. I'm not 100% on that, but let's just kind of see what that looks like. That looks like a bug, so that's not it. It would be interesting to look at this backwards iteration. And the way he works is he says, hey, if I am still within the amount of like backtracking that I'm allowed to do, I'm going to say, hey, where did I come from? What are like the x and y values on the grid associated with that value? Let's find our current x and y and our previous x and y. And then if we are in a case where our x and y both have changed, we have some sort of diagonal, and we like shove the diagonal in there as well. And so I want to just see maybe what we are doing here. So maybe here I'm going to say caching a move at some position, caching a move, and so I guess here it's going to be whatever we put in here. And then here we will say returning x, y. Okay. So this should at least give us a little bit of a clue. Just a little bit. So I guess here we're seeing that he's returning 0, 1, returning 0, 0. And then here he's saying caching a move, 2, 0, and then returning 3, 1. So this is 3, 1, 2, 0. And he is returning 1, 1 as well, actually. Oh, hold on. This might be for different lines. Hold on. Let's show this as each line that we're trying to return. So we're going to say print line, starting new line. Or maybe we'll even write for the k value. For k is k. Let's just take a little peek-sees there. Okay, so starting new line for k2, and he caches a move 2, 0 and returns 3, 1. So it looks like we're just not... Caching a move 2, 0, returning 3, 1. So he returns 3, 1. Oh, and then here we also have to say... there's some early returns here. There's a log here. So returning... xy, which is ret.0, ret.1, and then here we'll say limit reached. So this should give us some info, Continue to bisect. Okay, so here we say caching move 2, 0, returning 3, 1, returning 2, 0, limit reached, and it feels like it feels like it does just need to go one further. It does feel like our limit is off. Like it really does feel like we should be going back in order to see where we came from, I guess. Hold on, let's think about this. Returning 3-1, returning 2-0, returning 1-1, returning 0-2. Yeah, it does seem like we just have to go one back. But then there's probably some like limit at the edge that we're not handling correctly. So let's... Yeah, what the fuck is happening here? So now he's returning 2 points, which I think makes sense. Let me just make sure that, like, we're not like in like a totally fucked state. Like, do our tests pass right now? They do. I feel like I'm going crazy. So cargo run. Cargo run. Let's just see. So we move. This is already fucked up. Right? So we're starting a new line for k equals 0. We return 0, 0, and we cache and move 1, 1. It's like, what the fuck is happening here? That doesn't seem right at all. Well, because if... Let's print out our d and k values. D is this, and k is this. Boom, boom. Okay, wait, we can just look at the first one. We don't need to get crazy here. Boom. Okay, so right off the bat, we have D0, K0, and we return 0, 0. That makes sense. But then he's got like this extra piece here. So then he's going to D negative 1. And very clearly, D negative 1 is an insane thing to be trying to do here. So maybe this should be less than or equal to, but then like... Okay, that's fine. But now we're back in... This is like exactly the state we were in before. So why is this guy not returning this node? Because we're... Oh, I see. We're giving like our current position, but we need to give our last position as well. And if we're at the limit... I think it's that if we're at the limit, we want to return one last thing before we call it a day. And I just must have fucked this up when I was refactoring yesterday. So we'll still say that the limit is here, but when we're at the limit, we do one last thing. So if self.d is less than self.d limit, cache one more move to show where we came from. But this is only one cache. We might have shown a traversal. So maybe it's like I'm missing something. I am missing so it's so obvious. It's so obvious. We just need to return 3. We need to return 1, 2, or 3 points. So maybe what we'll do is we'll cache many of these guys instead of just one. And then here... No, I'm missing so I don't get it. I don't get it. I guess there's a special case where we're at the limit. So we have a graph. Boom, boom, boom. Simple move, right? So our iterator is pointing to this guy, and he's saying, hey, what was my previous position? And my previous position is here. Okay. Then he says, hey, if I have like a diagonal move, I'm going to cache this guy. So then he returns him. He returns this guy. Then he has this cache version. He returns him. And he goes, I'm at the limit, so I'm going to stop now. But really, when it's at the limit, we just shouldn't go back here. At the limit, we still want to return one more. So it's actually, if this is less than d limit minus 1, or we can go back to just providing d minus 1 here. But then we're hitting a bug related to this, where this back here is invalid memory in the case of our forgetful iterator. So that's probably where the bug was coming from, is he was seeing like a diagonal move when he shouldn't have. Okay. So here we should only do this traversal. We should only look at the previous thing if we're not at the d limit. Right? Yeah, I think that makes sense. I think. We'll find out. Okay, that looks... yeah, that looks right. So this is showing, like, one move. And if we do the non-forgetful version, boom, 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 everything looks okay. If we do the backwards version... off by 1 here on our backwards iteration. Confusing. Maybe this guy needs to be limit -1. That sounds possible. No. Fuck me, man. Stupid coordinate spaces, man. It's so hard. It's so hard. Unless... What is my... This is the same box, right? This is the same box on forward and backwards? Yeah, it is. Okay. Click next once. But he is starting over here. So it could be that our, like, backwards iteration is ending at the wrong spot. But I don't really understand why what I just changed would affect that. What did I change? I changed delimit, self delimit. Nothing changed here. On the non-forgetful path, we just said if self d is greater than d limit, we look at the last thing. But when the limit is 0, I think there's a special case at like d limit is 0 as well. I'm just gonna do this. I'm pretty sure that's it. Pretty sure there's a special case at d equals 0. Yeah. I see. So it's because there is a traversal, there's this like diagonal at d0. This guy like immediately shoots up to here, and so we were refusing to look at d-1, but d0 is here, so we need to draw this like original line. Yeah. I think that makes sense. Okay, fix forgetful viz. And let's just double check cargo tests still pass. Pretty sure that that's fine. Yeah, that's fine. And then if we visualize a full backwards pass without any limits, that's fine. Looks like it's behaving correctly. And then we do a forwards pass. Also looking correct. Yep. And then I think that's all the combos. Oh, forgetful. Yeah, we're chilling. Perfect. Okay. All that done. And we are at 2450. And we are on run forwards and backwards and visualize. I guess we should nuke all those print lines that we shoved in here. Boom, boom, boom. Uh-huh. All right. chillin', and now we can say git add -u, git commit -add, amend. Okay. Okay. So run forwards and backwards. So maybe we look at our libdiff, and he constructs, or sorry, our diff visualizer. He constructs this like algo, and he constructs them in forwards or backwards mode. And so I guess like the whole algorithm is, fuck, my fucking thing just crashed. The whole algorithm kind of runs in two states now, I guess. There's like step 1 is forgetful and find intersection points. Step 2 is build diff based off sub problems. And this is going to have like some algorithm that contains a bunch of sub algorithms. And just for the time being, I would like to leave the existing usage of diff-algo as completely valid. So there's like two options here. One is we could add like a, linear mode to this guy. But I think I don't want to do that. I think what I want to do is I want to construct create a new thing that is like linear diff-algo or something. I don't know. We might come back to this. Fix me, maybe merge with diff-algo. Okay. And what is he going to do? He is going to have like some algo. Forwards is going to be a diff-algo, and backwards is going to be diff-algo. Right? So he's going to have two guys, and he's going to walk them at the same time. And I guess he's going to have some sort of meeting point. Which is going to be like some coordinate in XY. And where this gets complicated is he might end up making like sub boxes of himself, right? So once he finds one meeting point, he might create two sub algorithms based off that. At like that are more of himself, right? So if we have like grid, and this is like where he's working, he might end up constructing like one guy here and one guy here, and so then in this, these guys might construct one here and one here, and this guy might construct one here and one here. So I think that's right, where we're going to have sub things of myself. And I guess we can just kind of start writing code and just fucking see what happens. The visualization just clicked for me. A path of all down, then all right means delete every line from old, then add every line from new. Slightly, almost. It's back. What you have is backwards. The right is delete, down is add. Because like here, if we're going from the string 1, 2, 3, 4, 5, 6, 7, 8, and we have the destination 3, 4, blah 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 blah. Rightwards kind of means like I'm doing something related to A by itself, and going downwards means I'm doing something by B by itself. So it's just delete, add, yeah. But yeah, it took me a while to get the visualization as well, which is kind of, it's indicating that I'm not doing a good enough job explaining it. I'm moving too quick. But sometimes that's just how it goes. Okay, so for each step of this like linear algo, I guess we're also gonna have to keep track of like the current state. So we have like we have like this for building up our snakes as well as running the like backtracking version. So linear algo state here is going to be like snaking, we'll call it, because that's what they call it in like the paper. They call it like middle snake or something. And then we'll say diff building or walking backtracking. I like that name. That seems reasonable to me. And so he's going to do something. He's going to need to take in the same inputs that we have in the sub algorithms that he's running. So function step is going to take in A and B. And I don't know if he's going to return anything yet, so we'll just do nothing for now. And he's going to step A and B. Now, he needs this step function moves across one how do I say this? Let's cargo run this guy. Is he gonna compile right now? I hope so. Let's look at, okay, we'll screenshot this. Export, color paint. And we're gonna need to change the fucking color. There we go. And so each step of the algorithm does like one move this way. Right? So he's gonna go like this, then this, then this, then this, then this, right? Then this, then this. Oh, sorry. Then this, then this, right? So this is like one step in terms of like one iteration of the loop as we care about it. But the outer loop kind of only cares about like full diagonals. So maybe it would be kind of nice to say that we have like multiple states. We have like a finished state and an in progress. But maybe at each step we kind of tell the parent, hey, this is what I just did. So maybe we say like D finished. Maybe we say we'll change in progress to like this is like I K incremented. And maybe we'll rename this from diff algo state to like diff algo action taken. Damn, catching a second stream in 1 week, my sleep schedule is fucked. Hey man, I'll take it. My indexer, I can hear my fan spinning, so he's just taking a long time to try to say that. Okay, diff algo act taken. And so then we'll just make another one that's de-incremented. Okay, and so now we just have to notice that state in the sub algorithm. And so here we're gonna have to get a little tricky. Else if this is a little bit of a lie because we're like kind of claiming that we've incremented D here, but we don't increment D till the next iteration of the loop. But for now, we'll just kind of allow the lie. So we'll say like else if self.k is greater than self.d. We're going to say return diff algo action taken d incremented, and then we'll just put a little note. This is technically a lie, but in order for debug info to provide useful information about what we just did, this lie is useful to us. From the caller's perspective, they don't care if we increment at the end of this iteration or the start of the next. There we go. That's fine. What's your day job, by the way? Your background sounds super broad. Okay, so right now, I have no day job, which is sweet for me. I'm taking like a bit of a year off just to like reset, you know. which is, yeah, it is what it is. And what I did before, I worked at this like security camera company. So I was working on like software for like rendering. They had this like software for rendering streams from multiple cameras and like recording it. So I worked on that for a while. I worked on like the camera firmware itself for a while. So like, you know, someone hands you a box and they say like, make it go please, and you know, you have like some vendor system on a chip and they give you some like distribution of Linux or something, or like some, you have like some microcontrollers that have like some sample code or whatever, and so you have to do like put all these pieces together and like write some software that like takes video stream from camera, put on network, right? Nothing, which sounds like, the whole time I was there I was like, why do we need so many fucking people for something so simple? But it was a lot of work. And then I worked in like this like neural network company for a little bit, where we did like basically like 3D. I'm trying to like think about like how I can say this in a way that it's not they're not going to be mad at me for saying it. We did like estimation of the like location and orientation of an object based off of two cameras. You like stick two cameras in the sky and you point them at this thing, and then you can kind of like, by like looking at things from the left eye and from the right eye, you can kind of figure out like, if you know where like the same point in the real world is, you can like figure out with a little bit of high school trig where it is relative to your cameras. If you know where like your eyeballs are relative to each other, and you know like this pixel is the same as that pixel, you can figure out where it is in 3D space. And so if you have like a bunch of points in 3D space, you can kind of like figure out if you know that you're picking up like a soda can, you could look at the points of a soda can and kind of like correlate, well, okay, like there's like a one axis going this way, and like you could look like the tab and be like, oh, okay, so it's pointed like kind of like this way, and this way. And so we did like neural network shit for that. But yeah, background's not super broad. That's like 2 jobs essentially. The broadness is more from probably shooting the shit, I guess, like stuff like this. It's just like, I do this for fun. This is my hobby, which is like a stupid fucking hobby. It's like you go to work and you code all day and you come home and you code all day some more. It's like, fuck, what the fuck are you doing? But I find it fun. Was the pay good? It was always wild to me that you can build React apps for like 200K instead. It was not 200K good. I'll say that. But I also, you know, I don't live in like the valley, right? I live in like Vancouver, Canada. So pay here has always been like not competitive with other places. But I mean, dude, I can't complain, right? It's like, it's so crazy that like, this is just like a fun thing that I do. And they just give you like, even like the like low pay is so much money, right? Like I like way more than I needed, right? I have enough banked that I can take a year off and it doesn't hurt me at all. So whether or not the pay was good is, I don't live in the valley. I just live in one of the most expensive cities on earth. Yeah, it is expensive, but the pay is not competitive. So like the pay of software developers here relative to the cost of living is like nowhere near as good. But again, it's like way more than enough, right? By some metric of enough, right? I mean, obviously, your mileage may vary based off of your desired cost of living. I also am very lucky that, well, I don't know, maybe not lucky is maybe not the right word, but it's not like I have like dependents that I'm taking care of, right? It's just like I live by myself and I live in an apartment, and it's like, I don't know, my expenses are like food. And so it doesn't really, it's not a big dealio. Okay. What were we doing? We were trying to make some collector of algorithms. So he's going to run the forwards pass and the backwards pass, and he's going to run the forwards pass until de-incremented. So while self forwards.step is equal to algo action taken k incremented. We don't care about k increments. And then we do the same thing for the backwards version. And then we need to do some sort of check for if the two guys intersected with each other. Fix me check for intersection. Yup. Okay. And then let's, for now, just start trying to visualize this. Right? Because I think that we should try to make incremental visible progress. I think that's always better. So maybe we'll say that we have some sort of linear algo debug info. And he is going to have the debug info from both guys that he's sitting on. For now. Like, you know, in the future we're going to have to like expand this to all of the sub algorithms and stuff. But for now, we can just say we have like struct linear algo debug info. Well, your streams are definitely motivated to try to code for fun and learning after work and finally try to see Rust. Well, that's great. That's really good to hear. I will say that part of the reason I quit my job was because I couldn't keep up the pace of doing things off of work that I wanted to, right? So it is draining. Like, I don't know how much your job eats your soul, but you know, if sometimes you just go through a whole day and you're like, I just want to go home and sleep, like, and it's hard to continue to make progress. So I wouldn't beat yourself up if you don't get as much done as you'd like. So this is going to have some sort of like forwards debug info and backwards debug info. I mean, I say your GitHub projects with a lot of Rust. I really like Rust. What can I say? Like, it's just like the default at this point. You know, I've never written, like, work was mostly C++, I guess, and Python. But Rust, I think, aligns ideologically a lot with what I like, which is like neurotic levels of type correctness. Like, right, like the whole ecosystem is kind of built around this like impossible to represent invalid states idea. And man, do I like that. Like, as someone who, as a user of stuff, I like it when I can't fuck it up. Okay. So he's gonna have to like give this stuff back. So he's gonna say what? I'm gonna have like linear. I only believe that because you've never seen my Rust. Well, yeah, lots of people can not do that, but I think that like the major libraries, like the standard library and like big libraries that people use often are like, they're kind of like built with that expectation in mind, and like it's viewed in the community, I think, as like kind of like a bug if you don't do that, which is like, you know, that's not really about the language, but I do like the way that works out. So we're just going to extract the debug info from the forwards and backwards passes, which is easy. Then all we have to do is in our diff visualizer, we're going to have to find some way to construct this guy. So let's just, for now, pub function new is going to return a linear diff algo. And he's just going to create one forward and one backward version of the diff algo. So, are we going to allow limits for this? I guess we should. So maybe he's going to take in all the same arguments that this guy takes in. And I guess he's going to have to also have like this like type dumbassery, which is, I guess, just a generic with no parameters. I guess that's all we need, because probably all we do is look at the lengths. Is the linear algo an alternative to the shortest snake algo? I think it is the shortest snake algo. I think. I don't know. We'll be honest, I don't really know what the fuck I'm doing. But we're looking at doing the walk with no memory to find these like meeting points, which I think that I've seen called snakes in other places. So I think this just is shortest snake, but I'm not really sure. So our forwards algorithm is just going to be diff algo new. Do we want to go straight into forgetful? Maybe we'll start with like full memory versions for now, and then jump into forgetful at the end. Because I think that the visualizations will be easier if we can remember everything. So we'll just put a fix me here. These should be forgetful. And we'll do the backwards version here too. And then we just say linear diff algo. He's got forwards, backwards. Meeting point is going to be, why is this a vec? This should be an option. So we have no meeting point yet. Sub algos are empty. And the state is linear algo state snaking. I'm actually not convinced that this sub algos thing is going to exist, so I'm just going to delete it for now, and we can come back to it if we need to. We'll unwrap here for now and fix it later. Okay. Simple. So if we go into our visualizer, we now just want to, instead of constructing the diff algo here, maybe we want to keep the feature of running the original algo, and we'll just say if somebody says that they want the linear one, we will allow it. But then we'll just say that if linear and backwards or forgetful, fuck off. Linear is linear alone. I guess we should tell exactly why. No backwards or forgetful with linear. It's fine. Fuck it. Fuck it. I don't know if there's any difference either. I've tried messing around trying to do this in Zig. How was it? I've been like itching to try some Zig. I just haven't done it yet. But it looks like a pretty sick language. Pretty sick language. Okay. So I guess here we're going to return a diff algo, but I guess the problem here is that like now it might be a diff algo or it might be a linear diff algo. So we're gonna have like GUI diff algo or something. Fix me awful name. And he's gonna have like linear, which is gonna be a linear diff algo, or full, which is a diff algo or something. I don't know, like whatever. Whatever, man. So this guy is going to need to look at the linear diff algo. Piping, piping, piping. So boring. So for now, we just adjust the types so that GUI diff algo full. We will just try to get it compiling before we add the new thing in, just to make sure we don't break anything. So slap some fulls on here. Great. This guy needs to be over here. And then his storage, wherever that is going to restore a GUI diff algo. And I guess here, it's just going to be, he's going to, the stepping logic is going to be the same, probably. So we're gonna like match self algo, and if it's the GUI diff algo full, we do x.step self.a self.b. We're gonna do the same thing for linear. And then we have to check if it's finished. So right now we have no real way to check that in the linear version. So for now, we will only do that check in the full version, and we will just fucking fail on the... We're probably going to crash on the linear version, but we'll live with that for now. So this should say algo. And we should say if algo step is equal to algo step taken finished. We flag ourselves as finished. Okay. It looks like we fucked up some brackets somewhere. Probably here. I guess this indenting looks fucked. Can we do that? That looks better. That's like easier for me to like track. And then here, we're going to have to look at which version of the algo we're running. So here's going to be self.algo. And all of this stuff that we were doing before is going to be GUI diff algo full. We're going to do some stuff with his debug info. And when we're in the linear version, we don't know yet. Okay. Lots of reference bullshit having to happen. So this is mute. It's an and. Is it like this? There we go. It's like this. So this guy, like, boom, boom. Okay. And looks like we're good. So now we just need to hook in the linear section. So we say construct diff algo. We're going to say if args linear, we construct a linear thing. And I guess we'll split out a constant for this. So max mem bytes is equal to, it's a use size of equal of 100 times 1024 times 1024. And if I cared more, I would split out a constant for bytes to megabytes. We'll just say 100 megabytes here as a comment because I don't really give a fuck. You can't stop me. Max mem bytes. Okay. Looking good. And so now cargo run, and if we run linear, we're gonna crash. Probably no, we're not gonna crash. We're just not gonna render any of the debug info. He's mad. What's he fucking mad about? Panicking at get mute at line 251. So this is at diff algo step. Index out of bounds. Length is 153, but the index is 153. The fuck? Okay, so in the non-linear version, we're still good, right? Yeah, we're still chilling. Okay, so this is in the linear version. We constructed a new thing. We called step. And we have this while loop, right? So are we flagging things correctly? I guess let's print line. Print line, step, and we'll log D and K. And just to see what the fuck are we doing. Oh, this is the... Oops, we want the linear version. Linear. Okay. So here he took a whole fuck ton of steps, which is wrong. Right? He's been... Right. It's because this condition is wrong. This condition is wrong. Much better. Okay, so we're getting to the end and panicking, probably because we're going out of bounds. Probably, I guess, but we'll see. We'll see. So let's get into our visualizer again. And now we can start doing some drawing in this. So first of all, drawing dots is unrelated to the debug info, so we should draw all the dots no matter what. But now, we are going to, I guess, we're going to kind of do whatever we were doing for the full algorithm twice, once per. So maybe we should split out a function for that, and that's going to be like function render algo state. and he is going to take in whatever the fuck he needs for this. So I guess we'll just kind of make the function first, and we'll just kind of see where he falls over. So I would like the debug info to be passed in. Here he's going to need a grid, which is a grid. These are no longer references. He's going to need some sort of stroke, I guess, which is going to be a stroke. So like, how are we drawing our lines, as well as a painter, where are we drawing them? Okay. And I would like to color the forwards and backwards passes differently. So I guess also, let's say the active color is going to be a color 32. And here we're going to say the move stroke is the active color. The rect stroke colors. This can be unconditionally cyan, that's fine. And I would like to pass in the color here. So somewhere this guy's getting this guy is not using the right color here. Yeah, perfect. Perfect. Okay. So this guy needs to pass in the draw moves. What is happening here? Move stroke. This guy just can use the external stroke. And then here we just set the move stroke color. Great. Bang, bang, boom. Which means that this guy didn't actually need the color passed in. He just needs not hard-coded as green. Okay. So now we can put all of this stuff in render algo state with algo debug info. And what were the arguments of this thing? Grid, debug info, stroke, painter. Stroke, painter. And active color. Okay. And then we just do the same thing here, but for the debug info is equal to algo debug info, and we just do it for the forwards, which has to probably be marked as public for this to work. So this guy needs to be pub, and this guy's gonna be debug info backwards. And maybe we do this guy in like pink. Red. Red green is bad because of red green colorblind. Maybe we do yellow. Okay. Not looking right at all. It looks like we're only drawing the forwards one, so I'm concerned that maybe this debug info is we didn't construct the backwards version of this, which is a good clue that we fucked up. Let's take a look. Okay. Looks like he's like mostly working. It's just this green dot should be fucking yellow. I don't know what he's doing. So that's in main. We are looking at the render active dot. And this guy's just using the wrong color. Boom, 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 boom. Sick. So here we're going to see that this would be like our meeting point. And we would split this into this and this. But we don't have any like early stops, so now they're just like clobbering each other and then crashing when we get to the end. Okay. So now what we need to do is we need to find some way to extract the current positions. So we kind of want to like go over each diagonal line, I guess. I guess first we should assert here, maybe debug assert, that self forwards dot d is equal to self backwards d. Let's just make sure that that's not getting hit. Okay, we're chilling. And then what we have to do is we have to say self. We're going to look at for each k in negative d to d. Well, not for each k. For k in self forwards d to self forwards d, and I think this is inclusive, and we're going from negative to positive. But we only step by every 2 because at each layer of the tree, we're looking at either even or odd k values, right? Like if we draw the tree out like this. Boom, 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 boom. The way that like the algorithm is encoding this information is like k is equal to 0. Here, 1, -1, 2, -2. And so that means that like at each layer of this tree of movement, we can only be working on like odds or evens because of like the way these line up. So we step by 2, and then what? We need to find some way to translate like the k values from the backwards coordinate space to the forwards coordinate space. So we're gonna have to say like, and then we're gonna have to look at the values in the trace. So I guess it's like self forwards trace for a given d and k. We're going to say here is the x value at this given dk. And we're going to have to say this is like the forwards x value. And then we're going to look at the backwards x value. Is equal to self dot backwards. It's going to be the same basically. Now, the only problem here is that the like backwards k is different. So the way that we've kind of structured this problem is when we run our algorithm backwards, here. We've kind of said a backwards walk is the same as a forwards walk flipped over x equals y. So if we just invert everything, all other code continues working for free. So the idea here is if we look at our... There's so many color paint windows. Just close them. Ow! Ow! That fucking hurt. That's so loud. Why? Oh, my dog didn't like it when I started yelling ow for some reason. Wow. I wonder what you didn't like about that. Okay, hold on. So a backwards walk is like as if... how do I explain this? It's as if we started, like this axis got put this way, and this axis put this way, and then we walk from the bottom. So the important like piece of info to think about here is if the x and y's do not lie, like they're different sizes. What the fuck? That's a bug. That's a definite bug. What the fuck is happening here? One sec. Let's fix that. So that's going to be on like draw grid lines. He's looking at the width and the height. And y in 0 to height, x in 0 to width. Let's try that again. Still something wrong here, for sure. Like, what the fuck is going on down here? This would be height. Oops, there we go. Much better. So if we were to like take this guy and export to color paint, and we were to start drawing the diagonal lines in here, so the problem here is that when we're going forwards, this is k equals 0, and this is k equals 3. But when we're going backwards, this is k equals 0. And I think this is k equals negative 3. I think. I'm not, it's either positive or negative 3. So we need to like do some translation of the k values from the forwards pass to the backwards pass in order to compare them. And what is that conversion? It is the width minus the height, it looks like. Just kind of looking at what we just drew here. K is 3 in this case, and that's width minus height. So let's just try that. So we'll say let k conversion. I guess we'll store the k offset in here. And so the k offset is going to be a len minus b len. And then here we're just going to say let backwards k is equal to self or k minus self k offset, because we're storing the forwards to backwards, not backwards to forwards. Okay. Yep. And then we will say if backwards x val, forwards x val, we're doing some comparison between these. I'm going to say if the forward x val is greater than the backwards x val, we have to define a meeting point. So we'll just define it at the end of the forwards for now. Fix me more intelligent picking. But for now, we'll just pick the first one that we see. We'll kind of say like, should we look at all options for this D? Where in the line should we, where in the collision should we pick? But it doesn't really matter for now. For now, we're just going to pick anything. And I guess it's maybe greater than or equal to. Because if they've met, they're good as well. And so then we'll just say now that we have like a meeting point is equal to sum forwards x val and k minus forwards x val. Because I think that's the conversion from k to y. Y is self of x minus k. It's backwards. Which, you know, probably should be split out into a function in some way, but fuck off. This needs to be starred. And then we break. And then I guess our algo state must change. Right? We've found our meeting point. I guess that's not really true. We've only moved into like the backtracking mode if all of our subproblems are also within the memory. But for now, let's just say that we only ever break it into 2, because that will make this easier for us. Our debug info is going to tell us now if we have found a meeting point. And then in our visualization, I guess we will say if we have a meeting point, debug info meeting point, we can render that. So we can say render somewhere we're already rendering dot, render active dot. Draw active dot. Yeah, there we go. So we pass in the grid. And then the... Fuck, I guess we just draw them. We draw it manually. Fuck it. X pause. is the grid x idx to xpos, which is meeting 0.0. Y is y1 circle radius, and the color, we're gonna say like color 32 pink or something. We don't have pink. Fuck. Blah, 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 blah. Fine, I'll just make a pink. I want pink. You know, you can't stop me. Pink RGB. 140. What is this? I'll take it, but strange. We'll just do this. So this is color from RGBA. I don't remember if it's unmultiplied or pre-multiplied. I don't really give a fuck. Doesn't really matter. He didn't like this K offset thing, so 368. This K offset was expected to be an I64, so right. And I guess we should really be doing try-intos here. Because there's a theoretical chance that the lengths are larger than what can fit in an I64. And can we do like... No, he doesn't like that. We have to say let a len is an I64 is equal to a dot len try into unwrap. Do the same for b len. And then we have a len minus b len. Gel. Now he's mad about u sizes in I64s and over here as well, so if meeting point dot 0 and is greater than 0 and meeting point dot 1 is greater than or equal to 0, then we draw it. Otherwise we give up. It doesn't fit on our grid. Okay. Why are we not drawing the backwards pass anymore? Hello? Oh, because we aren't running linear. Boom. Fuck. So live 248. This assertion is failing when we try to get mute because okay. Probably because this guy is like creating a backwards K value that is like out of range. So, I mean, we can double check that, but I'm almost positive that's it. I'm like looking at this and I was like, that's wrong. So here we need to only do this. So we can say like, if backwards K is less than self backwards D, or backwards K is greater than self backwards D, we continue. There's no chance of us overlapping because the backwards value for this K does not exist at all. Okay, so let's... Oh, wait, hold on. What the fuck is that? Why are we drawing a meeting point? Oh, because we have to invert the X values as well. Right, so backwards... We'll draw it. The backwards X value is actually this way. And so we need like, and this is 0 and this is like big, where like the forwards version, this is X and this is Y. So we need to invert this because of like the flip bullshit. Okay, so we have to say backwards. It's like we have to do something like backwards X val minus backwards K gets us the backwards Y, which is the forwards X, but like from the other side. So then we have to do like another transition that goes like a dot len minus backwards X val. But I think there's like a +1 in here, maybe? Maybe? And then we shouldn't actually be looking at a.len. We should be looking at like the backwards limit. So it's like backwards right value. And then let's just double check that in our debug info we're doing the same conversion there. I'm pretty sure it's +1, but he's not doing a +1. Let's just see what that does. Okay, so he's bitching. I64 cannot be dereferenced, so we do this. And now we see if there is a sane meeting point. Oh, he's being drawn here. That pink is not very strong, so it also doesn't look like the one we saw on... Oh, it does. I just don't want this one. Give me, like, a brighter one, bitch. Give me, like, this guy. R... Oh, so this is just max R and B is what I want. I want blinding colors. None of this, like, pleasant color bullshit. Hurt my eyes, please. Okay. So he's meeting here, and do we believe that that is the correct meeting point? So here, nobody's met yet. And here, that is like a sane answer. I guess here would have also been fine. This might be like a little bit too biased towards the right side. Can we go back to one with like... Here, let's go back to this guy. Boom, 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 boom. That seems reasonable to me, right? That's not crazy. That is the first meeting point. Okay, let's try like 2, 3, 4, 2, 3, 4, 5, 6, 7, 8, 1 or something. That meets here. That's super reasonable. Super fucking reasonable. Yeah, that's pretty sick. Pretty sick. Can we, like, I wonder what, like, another useful test case here is. Like, can we do something like 8, 8, 7, 7, 1, 2, 3, 4, 1, 2, 5, 5, 5 or something? I don't know. Like, fuck it, I don't care. Boom, 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 boom. So we should see a meeting point somewhere here. It'll probably pick this one. Yeah, okay, that's pretty sick. That's pretty sick. I think that's working. I think that's working. So I don't really know when we did this because I wasn't paying attention, but we can kind of say sometime that I just don't know. We found a meeting point. Okay. So now we have to split this into like sub-problems of some form. Okay. So in the case where the meeting point is valid, maybe our algo state is like kind of like extra like superfluous, is that the word? Information? Like we know that we've found our meeting point if there is a meeting point present. So what should he do in this case? I think these guys, do they need to stick around? I don't know. Probably not. Probably not. So I wonder if this is more like sorry, brain melting. Brain melting. For now, I'm just gonna do something so that I'm making some form of progress. And then we can always loop back and correct later when it feels like shit. So, forwards and backwards. These guys are going to immediately go away, which kind of makes me think that we're kind of like multi-state here. So maybe the snaking root is like we're trying to find the meeting point in our forwards and backwards paths. And so he's going to have this forwards and backwards diff algo associated with him, as well as their k offset. But as soon as he finds a meeting point, maybe he immediately transitions into snaking children. Well, we won't have a snaking children state. Let's start right now by saying that we're only ever going to bisect one time. In which case, we are now in the backtracking state, and he is going to have a forwards and backwards diff algo again, but they're going to be like the memory full ones. Okay. And he's also going to need their k offset, probably. And there's actually, this is incorrect because there's multiple pairs of forwards and backwards algorithms. In fact, there is no backwards algorithm. We don't care about backwards anymore. We're only going forwards because we're doing the full quadratic version. So there's no k offset here either. But there's going to be multiple. There's going to be multiple algos. We're going to be running each one. Okay. That makes sense to me. So maybe then we say everything that we have in the whole world is our linear algo state. And I guess, yeah, that's fine so far. And so maybe now what in our step function, I kind of like these guys kind of being in like their own structs instead of being members here. So I'm going to make some structs for those. So we're going to have like struct snaking state. Just going to have this. Yep. And then backtracking, that can stay the way it is for now. I don't really care. So now we can impl snaking state. And he's basically going to do exactly whatever we did here before. Boom. And the only thing that we're going to do is we're going to return from this guy. We'll return a boolean for now. Fix me, bool, return, maybe not the best. But now, instead of doing this, we're just going to return true. And here we'll return false. Yep. And so now here, we're not going to do any of this. We're going to say, well, we're going to do some of it. No, we're going to do none of it. We're going to say match self.state inner, maybe as a mutable reference. And we're going to say we are in the linear algo state. Snaking. And here we'll just do if snaking state step, if he has finished, we are going to adjust our current state in some way. I haven't decided how. And if we're in the backtracking state, oh, we are also unsure of what we're gonna do. We are overall fucking lost. We Why does it think this is unreachable? This guy can return false. He can return true as well. So what the fuck is the problem? We'll figure it out later. Here, I think that the stuff we return might depend on the state. So, but for now, we're just gonna say match mute self inner. And if we're snaking, then we'll return what we returned before. And if we're backtracking, I don't know what we're gonna do yet. You know, we just kind of we start, we add code, we cry, but eventually we get to the right spot. Okay, I guess this is just unimplemented. And this is snaking state here. Womp, womp, womp. This guy doesn't have a meeting point anymore. Ah, okay, so that's a good piece of info. So I guess as soon as we get the meeting point, the state of the previous walks are kind of like done. So in our backtracking state, we're going to have algos. And here we can say that the meeting will return some new debug info in this case, with the forwards and backwards passes empty. Right? There's nothing. We don't know what the fuck is going on. But the meeting point will be defined. He will be defined as forwards dot algos 0 for top right, and algos 0 bottom. This is the meeting point. And here, I guess we say this is sum. All right. Unimplement is unreachable. Yeah, I don't know why it thinks that, but we'll find out eventually. So here, it might be related to the fact that this snaking state is not, like, implemented correctly. So this is inner. Try adding a comma. Shut the fuck up. Don't tell me what to do, even though it's helpful. Okay. Self inner here. Oh, this isn't empty vet. Fuck. Can we... Does this guy have like a default on him? And if he doesn't, I'll just add one. Fuck it. This guy doesn't have a meeting point. Just gonna say none. When will we get to see the dog? I don't know if ever. Maybe at some point, but maybe not. I don't really have any plans to like milk her for content or anything. She's just chilling. Oh, maybe it doesn't like this like diverging. It says sub-expression diverges. That's probably fine. So self.inner is equal to linear algo state backtracking in this case. And here we're going to have to construct like some algos. So we'll get that algos is equal to vec new. And we're going to push them. So we're going to say algos push a new algo with we'll figure it out. So he's going to push a new algo. Okay, that looks okay. And his top is going to be 0, 0, and his bottom right is going to be our XY position. Did we lose that piece of code where he was calculating that XY? We might have. Yeah, so this guy has to tell us where they meet when he returns. So we'll say enum snaking state action I don't know, snaking state response call it, and we'll say he finished. And if he finished, we're going to give us an XY position. And otherwise, there's nothing to do. So here he's going to say snaking state response none. Here he's going to say he is finished, and we need to give him his X and Y again. Hopefully I didn't like full lose that code. It must be in here somewhere. But I might not have committed in a relevant time. And it sounds like I didn't, so that's kind of annoying. So his X value was the forwards X val, and the backwards, Y value was the forwards X val minus forward K. Okay. So now we can say if let snaking state response finished XY is equal to this guy, then we start at X and Y with 100 times 4 times 10 to 24, and we'll just say fix me max mem should be propagated. I guess we can take it from the forwards version, so we can say snaking state forwards dot max. Nope, it's gone. It's fully gone. So let mute algos equal to back new. Okay, chillin'. And then we need to make a second version, which is starting at X and Y, but going to a.len and b.len. Yeah. And fix me casting is sketchy. I don't want to think about it right now, though, so we're doing that. This guy's saying, please use vec to construct them in place, which I think is a fair assessment of what I should be doing. Yep. And now he doesn't have to be mutable. And if we step in this state, I don't know. I'm just going to do nothing right now. Uh-oh. Uh-oh. Okay. Cargo run. Does this compile? Does it run? We'll find out. So what do I expect to see here? They move in opposite directions, and then when they collide here, we crash. Not what I expected, but we'll live. So this is at 549. Oh. That's interesting. So here we're actually constructing something invalid. Why? Hold on. So here they're saying contains right is invalid. So let's just double check here that we got the ordering correctly. A, B, top left, bottom right, which is so top left, bottom right. What a stupid ordering. I just like shit on myself with that. Like that was obviously gonna happen. Okay, so now we have a meeting point up here. Is that the right meeting point? I'm not convinced that's correct. Right, it's down here. So the X and Y are probably inverted. Yeah, because again, it's just like top left, bottom right. What is... It's fucking stupid, but we will live. Okay, so now we have this. And if I hit next, it'll probably just is printed because we're not stepping this algorithm anymore. But now what we probably want to do is we want to show the two subregions that we are diffing now. So first of all, let's fix the algo state here. So what are we going to do when we get our debug info here? We have, right now we're saying here are our forwards things and here are backwards things. And maybe we can do like vectors of these. Or maybe we'll just do infos and we'll just push them all. So that way, the forwards and backwards passes, like either we're doing many forwards, many backwards, many forwards, many and backwards, it's fine. We'll just show you all of them. I think that's reasonable. So here, we are in the regular case, we'll return a vector of the forwards and the backwards debug infos, like this, with no meeting point. And then in this case, we will just map. We will say self or algos, iter map, iter mute probably, x.debug info, collect. There we go. So now I have a bunch of infos, and then the meeting point is here. And I guess technically there should be multiple meeting points. But for now, we are only ever bisecting once, so I don't really give a fuck. Okay, so now in a main, we are actually going to be looking at many infos. So for info in debug infos, we are going to render some algo state of that info. But we have to pick a color. So maybe we say we enumerate this guy, and we say let colors equal to, oh, we can get really fancy. You want to get really fucking fancy? We can say let colors is equal to, and we'll give some options here. Color 32 green, color 32. What are my other options here? Pink. No, we were doing yellow before, right? Maybe we'll do orange, which doesn't have a thing, so we can look up the fucking... This is max half. Okay, it's this from RGBA multiplied, so it's 255, and then 128, 0. That's gonna be orange. And we'll just do 3 for now. But here we can get crazy. We can zip this with colors, iter, repeat. And so this will just say, hey, we're going to alternate colors forever. And we'll just repeat when we run out of colors. He doesn't like this for some reason, because probably this has to be dereferenced or something. Colors is a color 32.3. Oh, I see. So this is... Oh... Repeat is the wrong thing. I want it to repeat the whole iterator. There's a way to do this. Rust repeat iter. Cycle. Cycle? Cycle. So this is colors iter cycle. Yeah. We're getting crazy. This is already borrowed. Okay. So now let's just see what happens. Boom, 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 boom. Okay. So this looks wrong. Oh, because the backwards pass... I don't even know what this box is, to be honest. Let's look. So I think that there's a couple things happening here. First of all, this needs to be backwards, like this. Which is part of the reason that it's fucking stupid. Was that right? Yeah. Let's try that again. And it's kind of nice. I didn't really expect those boxes to draw the right way. And now I think that we're close. This box seems correct. This box is fucking wrong. His width and height are inverted from each other. So let's... New backwards. This is a.len and b.len. What the fuck? New backwards. Bottom should be b.len. Right should be a.len. Top be y. Bottom should be x. God fucking damn it. God damn it. Okay, so now we boom. Oh, baby, that's so fucking sick. Look at that. Okay, so now we just have to figure out how to step these guys. And so for now we'll just step them in sequence, I think. So maybe each algorithm, he needs to store his own state. He needs to say, am I finished? And when we construct him, we're going to say, I'm not finished. And then that way we can call finished on him when he's complete. Is that what I want to do? Maybe that's not what I want to do. Fuck that. Fuck that. I changed my mind. Instead, what I want to do is I want to say, when we're backtracking, we're going to say current IDX. And it's going to start at 0. Yes, yes. And when we step, we're going to look at the algos and the current IDX. And if current IDX is greater than 0, we do nothing. Or sorry, is greater than algos, greater than equal to algos len, we do nothing. But if he's not, then we can do something with him. So we can say algos current IDX step A and B, and we can say if this is equal to algo action taken finished, we say current IDX plus equals 1. And maybe we're fucking chilling. Maybe. Seems like it might be right. So you go bum 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 bum. Oh my god. Oh, so this guy actually shouldn't be backwards. I'm a fucking idiot. I am an idiot. So this should be forwards. Okay, but we do need to look at make sure we got all the arguments right. So this is top, Y, bottom, top, Y, left, X, bottom, B length, right, A length. Okay, let's try that. Let's try that. Boom, 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 boom. We can. This guy is working fine. Oh, it's beautiful. Oh, that's beautiful. Okay, and now let's see if this is the same, like a good enough path. So this has like 1, 2, 3 diagonal sections. So we'll do the nonlinear version now. And we'll see if he comes up with the same answer. 1, 2, 3 diagonal sections. Now the only difference here is that the linear version decided to take this path instead of this path. But it's because we have 3 5s at the end, and so it's like which one is the traversal and which one is the addition or removal is like not really, which ones are the additions and removals is like kind of ambiguous. So I'm okay with that. So we can like screenshot this and kind of keep them around for later. And then we can run it again with the linear version. Oh, fuck, that's so sick, man. That's so fucking sick. Yeah, not bad. So the only difference here is in the non-linear version, he ends with the 2 adds of 5. And here he adds 2 of the 5s, then deletes the 3 and 4. Okay, so I think this is done. And at some point we kind of did some sort of like run subproblems, split into subproblems, only 2 we'll call it. And now I would like to be able to convert these 2 subproblems into like one big diff at the end. I think that's the next step. I don't know what's going on, but that looks awesome. Yeah, sorry. It's hard. It's really hard to make sure that people who are coming in midstream have any idea what the fuck is happening. But the idea is there's an edit graph here. So the idea is we're trying to get from let's see if I can try to render this. 1, 2, 3, 4, 5, 6, 7, 8. That's like the source string to 8, 8, 7, 7, 1, 2, 5, 5, 5. And the idea is if we represent this on a 2D grid, any horizontal movement is like a movement along the source string by itself with no change to the destination string, which kind of means that any rightwards move has to be a deletion. Because if you're like trying to get from A to B and you like move along A without interacting with B, the only action that you could be taking is a deletion. And it's the same thing when you go vertically. Vertically is only addition. So the idea is that like your diff that would be generated from this graph is +8, +8, +7, +7. Then here he has diagonal moves because we have a 1 here and a 1 here and a 2 here and a 2 here. So he goes like diagonally and he says like, oh, this part was like the same as yours source, and then he goes, okay, now I'm going to add a 2, add a 5, add a 5, delete a 3, delete a 4, and then like, oh, there's another diagonal move, and then I'm going to like delete 6, 7, 8. That's like what this graph means. And so we're kind of like walking the graph, splitting it into smaller sections, rendering the meeting point. So we're definitely making progress. Now the question is, 152, dude, I'm high. This is 146.25. Oh, kind of like a kind of edit distance. Exactly. This is exactly edit distance. That is what this is. This is like from a paper, Meyer's paper. He calls this thing. Where is it? Original paper. He talks about this thing as the concept of a shortest edit sequence, is what he calls it. I don't know where the fuck it is in this paper, but that's what he calls it. And then as a side effect of finding the shortest edit sequence, by doing that, you also happen to compute the diff that you need to make that sequence. It's the only way to get there. Or not the only way, but it's how we get there. Okay. So once we're finished backtracking, we can actually construct the diff in some way, right? And so in the old version of this algorithm, we did this by constructing a backwards iterator over the trace. And then we like constructed this diff builder that said like for each thing, I'm going to like push an insertion, a removal, and a traverse item. And this builder was like accounting for the fact that he's like, oh, if you push 2 insertions in a row, that's actually the same insertion. If you push 2 deletions in a row, that's the same deletion. And so we walk it backwards, we push these things, and at the end we have an edit sequence. So I guess in the case where we have multiple of these things stitched together, none of this actually has to change. It's just that we have to iterate multiple times. So we start at the end, we make our backwards iterator, we push into our builder, and then we do it again for each algo. So I think that that's actually very straightforward with the way that we've set this problem up. Kind of like by mistake. So here, I don't know if backtracking is the right word, but we'll leave it as backtracking for now. We'll put a fix me here, and we'll say backtracking and building diff sound like a very similar concept. But that's okay. We'll fix that later. And so now we'll just call this like building diff. Is that what we want to do? I don't know if we want building diff to be another state. We actually have all the information we need. What the fuck did I just say? We have all the information we need now. I was trying to say now and I said how and then I got confused. Maybe what makes sense is we'll just do it kind of like the same way we did it here, where we'll have like a function diff linear, we'll call it. And this guy is going to return some diff actions. I think it makes sense to not have this as part of the state machine, because the only purpose of the state machine is to assist us with like the visualization. But like real users of this thing won't fucking give a shit. I guess like theoretically, you might want to try generating a diff, and if the diff generation is too slow, you might want to be able to cancel it. So I guess like theoretically, there's like a reason to expose the state machine, but for now, we're not going to worry about that. So what are we going to do here? We're going to construct a linear diff algo out of this. we're going to say that this is unimplemented, so we don't have to think about satisfying the, whatever this guy's called, the fucking compiler. We are going to do just his step function. He has no indication of being finished, so I guess here we'll just say he's finished if the current index is larger than anything else. Or, like if we're finished the backtracking section, which means that now we can just say while algo step A and B, where U implements partial EQ. It's good enough for us. Then, once we are done that, we have our, like, everything is, all of the, like, information we need to build the diff is ready. So we've constructed diff builder, and we kind of iterate over the algorithms in reverse order here, I guess. So for sorry, I'm not really sure what I'm doing. We're gonna have to look at the things in the algo. So we're gonna say match algo.inner, which is kind of like fix me what the fuck abstraction violation. But that's okay for now. And what are we gonna do here? We have this linear algo state. And if we are assuming that he's backtracking, so we actually can do like let backtracking algos and current index. I guess we only care about algos. Is equal to algo.inner. Else we say like panic algo is not complete. Okay. Now we have our like algos to work through, and we can say for algo in algos.into iter reverse. We look at each one and we construct some like backwards iter is equal to, like, we're gonna look at like the algo d, I guess. And this is like the d limit. We're gonna go all the way back. X and Y, I think we're gonna look at algo.bottom or right and algo.left. And then we're gonna look at algo trace as well. Okay, and so this is gonna be like mute algo, I guess. And then everyone's probably happy. And then we're gonna walk the backwards iterator. Okay. In the same way that we do here. So I guess we're gonna say, hey, I'm gonna remember this last thing. And I guess the what is last here? Oh, we're trying to look at like the previous x and y positions. So we're going to assume that the previous x and y are just a len and b len. And then we're going to start walking the iterator backwards. Now the problem here is that we need to map the positions in the backwards iterator. So how do I let's see. Let's pull up and please still run. Fuck. Get stat. Oh, we're not in a state where we can run it. Okay. Fuck this. Is there? Okay. We'll just draw it out. So if we're in a state here where we have like one box here and one box here, right? In this area, all of our positions are going to be relative to here. So this position, even though it should be like, you know, x4, y5 or something, he's going to be showing as x0, y, or x1, y0 because he's in the sub box. So we have to like map these positions in some way. So we have to say map x and y. These are going to be mapped to x plus I'll go left and y plus I'll go top. I think. And then we can just do whatever the fuck we were doing here. So this is in backwards iterator. Okay. And now the only thing that we probably have to do is if x is equal to prev x and y is equal to prev y, this is probably like an edge case, so we just have to like continue on. Because we're going to hit one node twice, and that was like something that we didn't do before. That'd be fucking crazy if this worked. We can look here, and we can just, wherever we call diff in our... maybe we'll look at the diff. How do we want to do this? Yeah, we'll do this. That's fine. It's fine. So first, let's just make sure cargo check. Do we compile? We do not, because we fucked up. So 393 and wherever the fuck that is. So that's in diff is. Oh, here we just need to discard. I guess here we just say if x dot step self dot finish is equal to true. It's the same shit. Okay. And then let's run. Okay, let's make a test case, I guess. So let's look at let's take the previous version of this guy. No, I don't want to do that. We'll just make a simple test. So we'll say 1, 2, 3, 4, 5, 6, 7, 8. And we'll say 4, 5, 6, 8, or 8, 1, 3, 1, 3, 2, or something. I don't know. So we'll say diff a.text to b.text, and this will give us a clue of what we should expect this to look like. And we can even say cargo run bin spiff a.text and b.text. So this is a command line version of our diff tool. And so he's giving us what seems to be a reasonable diff with move tracking, which is kind of nice. This, like, there's a bug in the rendering here, so we'll ignore that for now. Maybe there's not a bug in the rendering. That actually looks maybe right. And now we can just take the spiff tool, and wherever he calls diff, wherever he calls diff, oh, this isn't the diff collection processor, recompute diffs, blah, 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 for diff in this, libdiff, here we go. So we can just, maybe, actually what we'll do is we'll just call this diff old, and we'll call this diff linear diff now. And he has the same API, so everything should still work. And we can see we get like the same thing here. And instead, we get a crash that says algo is not complete. Fuck you. So where is that? 717. Oh, because this should be while not. While not. Okay, now we have an assertion at line 248. So this is from iterating the trace. Interesting. And so this is coming from rust back trace is equal to 1. This is coming from get move source blah 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 blah. So this is coming from recompute diffs line 724. Which is, hello? Recompute diffs? That's not line 724. Oh, line 178. So it's here. Yeah, so they're just computing the diff and it's just fucking up. Why? I feel like this is new. I don't remember this happening before. So this is coming from get move source line 148 at line 849. So this is in the backwards iterator. Let's just print line getting move source for D and K. And we'll say, I guess we can't write those out, but we can write self.d, self.k here. And that should give us some clue. Getting move source for 2, 1. So D2, K1. Where is this coming from? Next, this is coming from 724. So this is in the backwards iter. Maybe this... Oh my god, did we fuck this up again? D limit x y. Okay. I don't see any problem there. Maybe we can look at what we did in when we extract debug info. X, Y. Maybe bottom and right are 1. Maybe these are like 1 too high on both of these. I wouldn't be shocked if there's an off by 1 in there. That would not shock me at all. No. That's still not. Getting move source for 3, 0, 2, 1, 3, 0, 2, 1. Yes, there's no difference there. Which is surprising. Let's run Rust GDB, target, debug, spiff on this stuff, quit, fuck off. R a.text, b.text, b rust panic, r backtrace. Let's just look around. We'll look around. So look at frame 10, and we are looking at self D, self K, 2, 1, like we were seeing. Can we look at like algo z? So we have 2 algos, one of which is 4. We have 0 to 0 to 4, 8, and 4, 8 to 7, 8. Oh, so there's a bug here where left equals right probably isn't being handled correctly. Almost certainly, right? Okay, so what are we doing in here? We're saying like P self D, P self K, and then the move source is how do I get like context again in GDB? GDB print source. No, I just want like a list. There you go. Right, so we are trying to look at the value of D at K plus 1. Which... Right, so we go D minus 1 is 1, K plus 1 is 2. There seems to be a bug here. K should only ever be... At D equals 2, K should be even, I feel like. Which is where this is coming from. So why is K not even? Print line new Myers backwards D K. Oops. New Myers backwards D3 K 0. And then can we look at like when we run the diff viz? Like is this supposed to line up even and odd? New Myers backwards D0 K0 D1 K1. It does seem like we're always doing doing evens and odds match up. Which kind of makes it seem like there's a bug in here where like this left and right doesn't feel correct. So here we check each x, y position given a dk. Where here we're doing something else. Okay, let's see what we did in this guy. We look at x and y, where x and y are a len and b len. Yeah. Oh, I'm a fucking idiot. This should be bottom. I fucking goddamn fuck. Okay, let's run spiff again. Closer, much closer. So this is at recompute diffs, diff 743. Unimplemented. Oh, right. So here we just say builder seek reverse. I think, is that what we do in this version? Yeah, we do this. Moment of truth, baby. Fuck. Oh, what's he complaining about now? Range end index, blah, 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 blah. At some form of, what is happening? When am I using rayon in this project? This is librs 909. No. libdiff 909. Calculate match score. Okay, so can we... I would like to at least see the diff that comes out of here. Calculate match scores. Okay. Match candidates, match insertions, removals. I just want to see if like we get a diff in here at all. You know? So here, we've at least gotten past this part. So I would like to see the diff that comes out. Okay. So we see a removal of 3, a traversal of 3, removal 1, traverse 1, remove... Oh, fuck hell. Okay, what if we just don't calculate matches here? Then our diff stuff should work okay, I think. So we can go into our spiff rs, and here we can just set an option to not fucking do that part. So it's something like request processor options. And then we can option set track moves equal false, and then we can request processor process new options. I don't know if this is going to be right. We might have to adjust like its initial state, but for now we'll try this. So this is somewhere in our backtrace. Ugh. Okay. What we'll do instead is when we recompute the diffs, we will just hardcode this to false. That's fine. I just want to see something. Attempt to add with overflow at 427. Hello? Am I fucking high? Oh, spiff lib 427. I see. So we're like trying to render this stuff out and it's not lining up correctly. I guess what we should do is we should run cargo test and just see what fucking happens. Like, surely all of these guys are failing too. Yeah. But we do see at least one case where it's doing the right thing still. Almost. This insertion at the end is the wrong length. No, it does not look right. Does not look right. Okay. We're at over 2 hours from now. I think that we are kind of... This might take a little bit longer. But I am happy with the progress that we made today. This is really, really sick so far. So at the very least, we're having some trouble with actually stitching it all together. But at the very least, in this visualizer, we are getting something that's like very sane, in my opinion. Right, we're having trouble like stitching it back, but at the very least, like that's a super, super sick set of moves we just saw. So we got to the point now where we're walking forwards, we're walking backwards. He finds a meeting point right here. Boom. We split into like this like sub problem where now he's running forwards again with backtracking in both sections. That's super fucking sick. So we've got all the pieces that we need. We're just like, there's a little bit left in terms of the stitching. But I think I have to call it for today because we're over 2 hours and I don't want to go for the rest of the day, whatever. So I'm going to call it there. Thanks for watching, guys. If you like what you saw, I stream most days at around 1 or 2 o'clock Pacific time for 1 or 2 hours. So if you're online in the hours of 1 to 4 o'clock Pacific time, you might want to swing by, take a look. If you're watching on YouTube, there's a Twitch link in the YouTube description. And if you're watching on Twitch, there is a YouTube link in the Twitch description where we have like playlists for all of our previous projects. We've done like operating systems. We've done virtual file systems, neural networks, web dev, 3D, right? We've kind of like done like a bunch of stuff. Whatever I feel like working on is whatever we work on. And there's no real rhyme or reason for any of that other than generally I like looking at stuff that I want to learn or that tickles my brain in some way. There's a GitHub link in the Twitch description as well where you should be able to see like the source code for this and other projects. Yeah, I think I'm probably going to take a break tomorrow, so I won't be back on March 20th, but March 21st we should be back at it. So thanks for watching, guys, and I'll catch you in the next one. Bye!